In your experience at ShareChat, how has the experience been? Like, what's the most challenging tech problem which came your way during this time?
So ShareChat has been a very good experience. In fact, that is why I have been here for 3 years now. I have been learning a lot where I keep on switching my domains and I keep on learning more. I initially started off in platform team. For people who don't know, like a platform team usually maintains the core services and infrastructure for a company, and they are the ones who are expected to go in depth and solve problems for scale. Like for example, if something is not solvable by product teams, they usually come to platform teams. So in ShareChat, when I joined platform team, actually I spent about a year plus working on a system which only did aggregations. The system was already built by someone else. I optimized a system which did aggregations for views, likes, shares, and all sorts of counters in ShareChat. It's a big enough problem where I could invest a lot of time. I read books on Kafka. I read books on Kafka streams. I looked at like KIPs, which is Kafka Improvement Proposal. I looked at the entire Kafka documentation, monitoring, set up all the like what each monitoring stat means and all those things. I went a lot into depth in Kafka and Kafka streams, which still helps me today, honestly. Like I'm quite fortunate that I got a team where like you're encouraged to go into depth. In fact, it's not that just they believed in me. Because I went into depth, I could also optimize things. I looked at like where is the issue here? Like why are we having so many pods? Like the we could optimize it. So in fact, this is pretty interesting. I optimized in the year that I spent on this thing system. I optimized the cost of the system by 95%.
Okay.
95%
So,
reduction in cost
yeah.
from when I started to when like a year later. I also recommend people that you should never like stay in a single place. Like you should keep on switching at least projects or domains. So a new project came in right after this, which I still consider to be one of the most interesting projects that I've worked on. It was building a real-time communication system. I'll explain what a real-time communication system. If you see like a chat app, that is a real-time communication
Hmm.
system where like I would say, let's say WhatsApp, Messenger, or let's say you have like the comments that come in on Hotstar, or let's say the comments that come in on some Insta Live. Like those are real-time communication system where someone posts and it has to go to everyone, or someone one is to one communication, or one is to many communication in real time. And those systems are a bit different from like a request response based system, like an API based system.
Hmm. Right.
And you have to build infrastructure to maintain those systems, and they have to be cheap and scalable usually.
Hmm.
So I we built a system on top of server sent events SSE to
Right.
maintain long lived connections between the client and the
Connections.
server at scale,
Yeah.
and we scaled it to around 4 million concurrent connections at peak.
On this point, I have a question. Like, if you considered other approaches, for example, like using WebSockets or long polling, like, why did you choose server send events as compared to these things?
I think those are like theoretical answers to it, and there is also like I would say an implementation, like an practical answer to it. Theoretical answer is that long polling, I would say, does not scale as well as SSC and WebSockets. Number one, long lived connections are cheaper both on the client as well as the server end if you implement it properly. Number two, SSC versus WebSocket. SSC is, if you have seen the protocol for both SSC and WebSocket, SSC is a simpler protocol, number one, and it has more support directly in the client. In fact, SSC is a part of the web spec, and it is like directly built into the web specs. And every I think web browser has can be an SSC client. In fact,
Hmm.
even in clients, they have very good, I would say, SDKs to integrate. I would say not just libraries to
God.
integrate, like clients to integrate. And then third part is SSC is more lightweight because it's unidirectional versus bidirectional. Fourth thing would be SSC is actually built on top of the HTTP protocol, like it's true HTTP protocol. Now,
Hmm.
I'll explain. It's a bit technicality. Like
Yeah.
WebSocket is a like if you WebSocket is introduced as part of HTTP 1.1. It's a, there's
Hmm.
a header that you send, like an upgrade header. But then once you set an upgrade header, like it's a custom protocol that then happens. Like it's built onto HTTP one, but then it's a custom protocol that happens. Like for example, you would know that WebSocket is still not available on HTTP 2 or HTTP 3. It still works on top of HTTP
Right.
1.1. SSC is
Right.
available on HTTP 1.1, on HTTP 2, and HTTP 3. Like it's a free upgrade. You upgrade to HTTP 3, you get SSC for
Right.
upgrade for free because it's a part of the HTTP spec. It's a part of the HTTP spec, and then there are gains to that. In fact, I'll tell you a very interesting thing.
Hmm.
This is something I discovered very recently. OpenAI, the Chat GPT that you see, the completion that you see on Chat GPT, they're built on SSC. In fact, yeah.
Okay.
I looked at their developer manual and I saw the SSC there. So they are built on SSC. SSC actually has some distinct advantages. It is limited, but the limitations are actually make it more powerful, I would say, for some use cases, not for all. Like for example, if I wanted to build a event processing system, like an event ingestion system, which would I probably use WebSocket or
Hmm.
now I we realized that for things like chat or in fact like it is mostly like we who send those messages. Or for example, like comments. Like if you see a comment on a live stream or comment on a real time system, usually it's a one to many. Like someone sends and then you send it out to a fan out. There's a big fan out. Even in one-on-one use cases, in fact, you get messages much more than you send because everyone is sending to you. But and then and the secondary part is usually you would want to send a message as an HTTP request because there are multiple things that you need to account for. You need to store it reliably in a database. There might be some
Right.
things like I am sending you in India and you're receiving in US. You have to account for things between different regions. So WebSocket, in fact, even Slack does. Even though Slack uses WebSocket, Slack does not use WebSocket for sending messages. They only use it for receiving messages. They use it for typing indicators, receiving messages, and I think some other things. They don't use it for sending messages. They have an API for sending messages because that
Okay.
API makes it more reliable. Like you have sent that message, you get that single tick. That API
Right.
makes it more reliable. I don't know about WhatsApp honestly. I think they have some custom protocols
Right.
like that.
Got it. So like all these platforms mostly they will send a HTTP request like a normal request response, and whatever messages they are getting they get through the server sent events. And the other approach which you mentioned is basically there is a WebSocket connection open and bidirectional communication is happening, and that yeah definitely doesn't that scale that much as compared to the server sent events.
I would say it scales, but like honest opinion, I would say that WebSockets, even though it's a popular technology, I feel it's a pretty like hard technology to handle. Like even today, I would not
Right.
want to operate a WebSocket server and then maintain all those connections.
Right.
I would in fact recommend for someone to build on top of like gRPC streaming. Like it's
Hmm.
more modern approach.
Hmm.
In fact, I would say a
Right.
lot of the companies that you see using WebSockets might just be using WebSocket because they are there from a long time, or they
Hmm.
might
Right.
like. I would want someone to build on gRPC streaming.
So, with these server sent events, if you come to the server side of things, how many connections per server were you able to create, like per instance?
Yes, yes. In fact, there's a very good talk by the person who developed Zool 2, and they have a this exact slide in this talk. Like why, like there was this fascination of like having as many I would say connections as possible per server, but that has its downside as well. Like because if you have a lot of connections, when that server goes down, because it is all on consumer
Yeah,
hardware, you would have a lot of connection churn. So
right. Single point of failure. Yeah, it
if you
becomes.
have a million connections on a server, you can do it. Then if the server goes down, million connection needs to be reconnected. That can cause a thundering hurt, right?
Right.
So there is, and if you have less connections per server, it's like wastage of compute, right?
Hmm.
So there's this Goldilocks thing. Have you like there's a
Hmm.
story like Goldilocks, like there's like something they have you heard of the story? I think everyone has read it as a nursery rhyme. Like Goldilocks went into a house, there was one porridge which was cold. She did not like it. There was
Hmm.
one which was hot. She burned her tongue. Then there's one which was just right, and then she loved it. So it's the same thing.
Right.
Like you cannot have less connections, you cannot have more connections. Both have their pros and cons. We settled around like 50K to 100K connections per node, and we tried to optimize the machine type and like the smallest machine type that can hold this many connections to have like optimal CPU utilization as well. So
Hmm.
that is what we did.
And how do you handle the failures? For example, one node goes down.
Yes. So interesting part that is why I love SSE. SSE has reconnections inbuilt into the like the client. So today, if you start SSE connection on your browser, you can do it directly on the like the developer the dev tools. If you have a server running, Node.js server running, and then you can connect it to it, and if you like for some reason your internet gets disconnected, you'll see that SSE keeps on retrying. The client keeps on retrying, and we took advantage of that. Like almost all client implementation have that retry. Number one, but then we took advantage of that, but we did not wanted to have like thundering hurt because let's say a node goes
Hmm.
down, 50 connection is reconnected, that's thundering hurt. So first thing is we have a load balancer in front of this, so load balancer anyways would distribute the connections across all the other nodes. So we have like just enough instances. Like let's say for example we have 20 instances in production, and let's say one node goes down, so the load is distributed across those 19 nodes. That is how is one way we solve this. Number one. Number two is we have implemented a very simple way of doing like exponential back of a jitter. That
Hmm.
is very important. Back of a jitter
Right.
actually solves for thundering herd, and we have seen this in production. If you don't have jitter, if you don't have exponential back of this thundering herd, introduce exponential back of a jitter, it's magic.
It'll fine. Okay.
It's magic. So we have tuned our clients to have both of these, and that is how we solve for like these. Like when a node goes down, we reconnect, but then we also ensure that the others nodes do not get overburdened. And in fact, we have tuned our HPA. This server group actually is autoscales on CPU. So we tuned our HPA to have some additional, I would say, compute left, so that even if let's say one or two nodes go down, the other nodes can safely take up the load. Unless there's
Hmm.
a coordinated failure, it should not have an issue. And nodes go
Got it.
down, go up and down every time because we are auto scaling. uh, at night we have more pods running, more nodes running at like our traffic peaks at night, like night 8 p.m, 9
Hmm.
p.m. But like at like say night 2 a.m, when there's no traffic, it goes back to min replicas. Like, so
Got it.
it's auto scale, so nodes go up and down all the time. In fact,
Right.
there is this philosophy, right, like Netflix of chaos testing. So in fact, our auto
Yeah.
scaling,
Chaos monkey.
yeah,
Yeah.
our auto scaling is our chaos testing. Like if this does
Okay.
not work, then auto scaling
Hmm.
would not work, because auto scaling keeps on
Right.
bringing up and down the number of nodes. So it will keep on
Hmm.
shutting down nodes, adding new nodes. So your system has to handle. In fact, we have this graph in production, and you would see that it's a very pretty graph. Like every time a node starts off, it goes from 0 to 50k, and then it stabilizes 50k. And then every node you see, this is like it's a very wonderful graph that you can see throughout the day. Like nodes stay stable at 50k, and then they go from 0 to 50k, and then stay stable there.
In this real-time system, suppose there are hundreds of people or millions of people basically liking or commenting. So on the server side, when you have to transfer these comments or likes to other people, you are you using some kind of batching strategy, or like for each like sent, you are updating it to the other clients?
We don't use a batching strategy. I think that was not a requirement. I can think about it. I think where you're getting at, I can also see where you're getting at, because Hotstar had a vlog on the same thing, how they stream a billion
Right.
emojis.
Right.
So I, in fact, like personally, I did not like Hotstar approach as much. Like I'm not sure why they used Spark streaming there. Like they could have used Flink
Right.
or Kafka streams. I'm not sure why. But then we did not have this use case. In fact, we have a two-layer fan out, which is how we can actually scale to millions of users. Because our architecture is a two-layer fan out, where there is a layer one, which is called a dispatcher layer, and a layer two, which is called an FE node, like front end node. And
Hmm.
what happens is each front end node contains 50k connections. Each dispatcher only sends a message to a front end node, and front end node has all the connections in memory, and it can send a message in memory. So
Hmm.
ideally, the last layer only scales to 50k at max. This layer scales to 20. Let's say 20. There are 20 FE nodes. So 50k into two is one. Like 50k into 20 is, I would say, 2 million, right? 50k into two is 100k.
1 million. Yeah.
50, 1 million, sorry, 1 million. So if you want
Yeah.
4 million connections, you have actually, I would say, 40 nodes running. And then you have two layer
Hmm.
scaling. Like each node can scale to 50k. The single, another dispatcher would scale to this, I would say, 40 nodes. 80 nodes, I would say. 80 nodes, yes. So we see that we can scale to million connections. It's just that we don't have a use case like Hotstar where we would need to do that. Maybe we might need to do batching, but we again, like I think I had only worked on another system in ShareChat which did all the
Right.
batching, so we can use it here. So
Yeah, so for like you mentioned just before this that you worked on the aggregation system where you did for likes and comments. There definitely you are doing some kind of batching. So how does that, like in that system, what would you say happens when a no, in a normal post, which is not a real time system, when a like occurs or a comment occurs?
So I can probably explain the problem statement to other people as well, because it's a conversation.
Hmm. Right.
So I will also, I think I'll link like my, I guess I recently gave a talk on this. I'll link my slides so
Right.
that can attach it, because that explains it more depth. But usually what happens is that a social media platform, there are some people, which are mostly celebrities, which receive a lot of likes or views. And usually these are the people who break the databases. Like, because
Hmm.
any database, whatever database you take, distributed system, be it a whatever you take, like it might be on AWS, GCP, does not matter. Everything will break if you have a lot of concurrent load on a single key, because that key is a hot partition, and that is overloaded. That partition is overloaded, and you cannot you cannot split that partition at least. So to solve for this, we use something called streaming aggregations, where we adaptively, like basically we batch those updates in our pods, and then we update do a bulk update in the database. That is
Database.
what solves the celebrity problem in the right path.
Hmm.
When you solve the celebrity problem in the right path, you actually need to do those aggregations. Like it does not matter if it's Justin Bieber or if it's Sukhad or Shubham or
Hmm.
whoever it is. Like all of them receive only a few updates instead of receiving like me or you receiving two updates and Justin you are receiving let's say a million updates. And aggregations have to be stateful because the pod, as I said, like pod might go down anytime and you cannot lose the data. So we use a system called Kafka Streams, which has a local data embedded database. It's built on our RocksDB. It's a local embedded database and it is backed by a changelog. So changelog is basically like all the updates that went into database gets stored in a changelog. The changelog is backed by Kafka, and since Kafka is a secure system and it has reliability and durability, even if the pod goes down, the pod can restore the state from the
From
changelog,
the change logs.
and it can continue taking the updates you don't have
Got it.
any lost updates. But this is an interesting system. Like I think we like I have only discussed till now, even in the blog post etc., about the right path. There is also a read path of this, like because
Hmm.
the celebrity problem also comes in the read path, because the right path
Right.
it's there, but a lot of people would be seeing Justin Bieber's post. They do not want to see you or me like on a step if they're not our friends. Like,
Right.
like if they do, that's great, but usually they don't, right? So in the read path we actually use caching is what solves. They can have like some sort of like a caching layer on top of the database. You can have
Hmm.
memcache, a centralized cache like memcache. Facebook did that. In fact,
Right.
Facebook built memcache for these kind of use cases.
Right. Right.
Or you can have like some sort of in-memory caching, or and a consistent hash ring on top of it, which today I think Facebook does that. They
Right.
have not published a lot on this, so I can only speculate.
Yeah.
There is, in fact, I think a great paper, Kangaroo, on the caching
Okay.
strategies that they use. So you can use a cache on the read part to solve for celebrity
Okay.
problem.
So for the aggregations part which you mentioned, what is the criteria of like when to like batch this and send for update? Is it dependent on some time, like 1 minute number of updates, or something like if the number of updates reach this threshold, then we'll update the database?
Yes. So we had a time-based aggregation. In
Okay.
fact, we had an adaptive rate where, like, for example, your post has less number of view counts. You would probably want it to update in real time. As a creator, if you have, let's say, 8 or 9 views, and then you see it updating real time, that gives you like an ego boost, I would say, and that's like pretty helpful for the
Right.
platform. But let's say you have 1 million views, and you don't care about one more view or 10 more views.
Hmm.
So we had an adaptive aggregation where, like, for example, like 0 to 100, there is no aggregation. 100 to 1,000,
Hmm.
there is like 10 second or 1 second aggregation. 1,000 to like 100,000 is like 1 minute, and then it goes to like 10 minutes of that sort.
So, like solving these two like very complex problems, you mentioned that you went into the in-depth details of Kafka and learning about those. How much did that information help, and how much someone should spend time in going into the internals, or just rather relying on like using the library and just using it directly?
Yes. So I feel that to a large extent, you can get away with, I would say, surface level knowledge and then understanding like how to use things. But that is if you have, let's say, a simple use case. For example, you work in a team which uses Kafka as like your team's main work is something different, and you're using Kafka just as a technology. And then you're using, let's say, publishing 100 messages per second. So that does not make much sense to go into depth. But in our case, Kafka and Kafka streams were what we did. Like the
Hmm.
cost was huge. This is what we did, and we had an opportunity to solve. Like if we went into depth into this and we solved for this, the cost savings more than outweighed like whatever, let's say, ShareChat was paying me, or like the time investment that was giving into it. In fact, my personal recommendation is you should go into teams where the scale is so high that they would benefit from you going into depth and solving those hard problems for them.
Hmm.
Like you work in Google, so you would see like how much depth people go
Right.
into at times, because they have this problem to solve. Google does not solve problems for the sake of solving problems. They solve problems because they have a problem and they go into depth
Yeah.
to build that, right? So if Google built MapReduce, this is because they had a problem with indexing. They could not
Hmm.
index at that scale. So I, I have always seen that if you work on those set of problems, you need to go into depth. And honest opinion is that you should strive to find such teams and problems in your career, because that is what in the long term I say helps your career much more, like than just
Hmm.
working on, I would say, surface level problems. Like,
So what if someone is not getting such problems and they want to learn it on their own? What's the best way which you will recommend?
yes, so in fact, a lot of people in the company have also come to ask this, and then internally in my company what I tell them is you should probably, let's say, see if you can work on such problems. Like ShareChat has good scale, and we have all teams working at high scale systems. So we can probably try a project with some other teams, a project that is being undertaken with some who are low on bandwidth, and then you can see explore those things. And we also have, like, just like Google, we have like some sort of innovation bandwidth, like 20-30% given to tech tasks.
Hmm.
So people should take up like complex tasks in that time. And then, like, for example, like cost is such a big goal. Like you should, if you feel that you can go in such depth that you can optimize the cost, that is always like encouraged by the company. So that is how we go into depth, and the same everywhere. But then let's say your company does not have these tasks, like
Hmm.
that is also a use case. Like some companies do not have like people working at scale or going into, they would not want people to go because they're just using it as a technology. They are user use cases. I would say it is difficult but not impossible. Like reading books helps. Reading, like doing contributions in open source helps. Going to, like, I would say, meetups and learning about things help. Like for example, I was just discussing with Sukhat before this call,
Right.
that I went to something called Bangalore Stream Processing Meetup, and like I would encourage more people to come with us to learn like what is possible like in this space, and then
Hmm.
probably you would get inspired to align yourself accordingly. Maybe you will change, you will work hard and then change companies so that you work in such a space which interests.
I think that that's a great advice, and thank you so much for giving that advice for the people. And all the things that you shared in this podcast, like they're really great. For example, your experience in itself is truly amazing. Like getting into quant and then being like a tech lead and solving all these complex problems. So we discussed two complex tech problems in this podcast, which like a lot of companies face today. And you also gave a great roadmap for anyone who is trying to get into quant. So thank you so much for taking out time.
It's always great. Like it's always great talking about all of these things, because I feel like as I said, like I have been a big fan of your post, and this is a good opportunity to, because I know that a lot of people watch these podcasts or go through these things, so it is always very great and helpful. Like if I can help someone, that always is good for me. Like I feel happy helping people, other people. I think like I have a lot of other things to talk about. Like for example, this is probably it for the podcast. Like I can probably like go into a little bit like where I like currently I actually am working on ML infra, more on ML infra side. I
Right.
think I talked to Sukhat before this interview. That is also
Right.
another interesting thing. And then I was talking to Sukhat like how like all of these things tie together. Like if you go into depth on one system, like if you're going to depth into streaming systems, then someone will come, okay, I want to implement something like real-time communication. I think you might be the correct person because you have gone into such depth, you can probably build this out. Tomorrow, someone wants to build an ML infra team and they see that ML infra is mostly stream processing because a lot of models are going real-time. So they would say, okay, this guy has worked on stream processing. I should bring him to my team to work on these problems, like these hard problems in ML infra. So I would recommend people to like keep on learning, to keep on exploring, to keep on doing new things so that they also continue growing.